For this seminar, I'm going to share a case study about how you could plan in advance such that you can save the project cost and project time for when you are developing the IoT products. So this is a general introduction of the segments of the costing which you are going to, when you are having a product designed. Here we have the hardware cost, we have the firmware, we have the charger, for example, and then we have the testing and certification. Testing and certification would be a quite large amount or significant amount of the whole development fee. So we have to minimize the fee that is needed during the whole development. And this is just an example of how the costing is separated here. We are using for example, the IoT smart home products, just like the Bluetooth light switch as an example here. The development cost is about 680K. But you can see with the testing, it would be about 150K. So we are now going to see how this project is going on. The plan here looks very good with the testing, with the software apps development, with the industrial design and so. But there is something goes wrong. What's happened? If you have planned everything very nicely and have your products on hand and go directly to the certification testing, that is what you are going to face. If your test fails, we need to have modifications. In many occasions, the PCB are already fixed, the Gerber is already fixed. You cannot change anything. So what can we do in order to pass the compliance or pass the regulatory testing? Add some lines here, intentionally add more components on the boards. That's ugly. And it's very hard to put into the manufacturing process as well. And in some occasions, you have to add another component riding across an IC. That's something I have seen in modification reports from the modification service provider. So if you have already fixed the IC or the component list you are using for when you are developing your product and putting it into the certification, you will have a very high risk of doing this kind of modification in order to pass the compliance. And you have to put it in your manufacturing line, which is very, very not cost effective. Sometimes you have to use this ferrite core in order to pass some EMC tests. There are lots of risks when you are applying this kind of ferrite core. One, it is expensive, and the other, the number of turns actually matters. If you have to add this kind of cores inside your IoT products, you will find this very hard to assemble later on because of the size of this kind of components. Another scenario that is not quite good is that in order to provide shielding effect, you have to add some copper foil or aluminum foil wrapping around your electronic device in order to minimize the emission coming out from the PCB board. The problem is you cannot change your case anymore, but you have to add something to it. So it is not quite feasible when it is going onto the production line. And the other things you would meet during your production is if you have to go through this kind of modifications, you have to conduct the test again, conduct the regulatory certification test again. For example, if you fail only one point of test, you have to retest it for many items, 2 or 3 items, because those items could be affected. So the cost of the retest will be high. And the other problems you will see when you are doing some design with the household appliances or design with the AC input ports, there is also a safety considerations. If you are adding that kind of foils or you are adding some other components on it, you are decreasing actually the insulation distance between your tracks and between the case and your PCB board. And that's why. That's what. After you pass your EMC or RF or regulatory requirements, you are going to fail your safety test again. That's the loop. And then you have to pay a lot in order to clear up this issue. Or you have to change your moldings, or you have to change your Gerber, and that's often too late. So it ends up with additional modification cost, additional retest cost, and if you are unlucky enough, you have to update your industrial design, and that's costly. We are not only talking about the cost, but the time. If you're failing your test, failing only one single part of test, you have to retest 4 or 5 items, and that takes time. For this project, if you are talking about a simple Bluetooth device, you may have an extra 1 month of retest. Remember, the whole project flow is only 7 or 8 months, and you have to waste 1 extra month in your testing. And for the modification and for the design update, it takes time as well. So what I'm talking about is planning is very important. How do you plan your test with your prototyping process? Of course, you need to know the regulatory requirements of different countries, just like what our other guest speakers has talked about, the Hong Kong requirements, the FCC requirements, or later on the European requirements. So you have to know what kind of test you are going to do or going to pass. And then you need to understand the test mode and test plan ahead before you are going on to the testing phase. I have seen some startups that they are not planning to make any test mode, and they all the way come up with a final product, final Bluetooth product. All the software is locked, and they pass it to the laboratory and think that the laboratory could do the whole test and set the test mode for them. It's not true. The test mode, in many occasions, should be set in the wireless modules, and the engineers should be prepared for that. And then I'm talking about the test plan. The pre-certification test is very important. Before you have everything fixed, including the PCB, including all your material and your design fixed, you need to do the testing at the prototype stage. So in the prototyping stage, you are going to define any potential issue that before the actual test. For example, if you're designing an IoT lighting switch, you have a concern about the radiator emissions, you need to do that part of the test before it is coming to the final certification test. By that time, you still have resources to change your PCB design, to change the selection of components, and that would save you a lot of time and effort later on. So it is very helpful with the current 3D printing technology. You may also have your industrial design in the prototyping stage using the 3D printing materials to have to go through the pre-certification test, such that if there's anything need to be changed, it could be changed in the computer drawing before any molding. So here is the testing items we are suggesting for the pretest. For the EMC RF, that would be the spurious emissions. You may use some pre-certification testing providers to help you to do the spurious emission testing. And you can use the bandwidth, you can do the bandwidth checking and the RF power checking as well. If you are developing the automotive-related IoT products, you need to carry out some testing for this kind of eMarks for the ISO 7637 and the CISPA25 to see if your products can emit from any interference or noise from the car battery or so system. For the CISPA25, there's some also other emission and immunity requirements. So it just gives you a very brief look and feel of what you need to plan before you are going to do the full prototype or the second phase prototype. For this kind of project schedule is what we normally suggested to our clients when they are developing their products. So we will separate the prototyping process into three phases. The first phase is first prototype. It's just a preliminary checking whether the design is okay. By this time, you can do some setting some test mode, and you can also do some pre-test as well. Once you find it passing, or you can go on to the second phase. Or if it is failed, you still have time, and you still have the flexibility to change your design such that it goes to the second prototyping. If everything goes fine with the second prototyping, you can do the, if there is any failure in the first prototyping, you can do the changes in the second prototype and do the pretest again. If there's nothing big changes from the first prototype, you can do the second prototype and then send it to the laboratory for certification. The third prototype you may serve as a buffer. I will show you later why I into 3 prototypes. Here is some testing facility at the pre-certification providers, just like us. We have a 10-meter semi-anchored chamber in Hong Kong for the RF power spurious emission. And besides the RF requirements, we are helping you not only for the regulatory, but also for the development, like sensors, durability. Perhaps you are developing the smart wearables with the sensors putting on your shoes, and if you walk 200 kilometers, your sensor is stressing for 200 pounds for several thousand times or several 100,000 times. So the sensor's durability, we can help you to set up the test fixture to do so. So the sound quality as well. It is suggested for you to set up a test plan before you are putting it into the real product. So there are also other suggestions, other items that you could use to do your pre-certification or the quality check. So just like what other speakers has talked about before, there are also battery power consumptions considerations for different IoT, especially when the size is going to be very small. You are going to use the CR2032 batteries. So this kind of power consumption would be a very important thing. And the communication range and RF sensitivity. You may check this when the first prototype comes out. You may check it yourself in-house in your development center, or you can pass it to, for example, us to help you checking the RF sensitivity and communication range. So with the pre-certification test considered, how much time could we save? And this is just a very brief idea of what it is. For the pre-certification, you don't need to test every single items that the retest should be. So you select 1 or 2 critical items for you to do the pre-certification. If there's anything wrong, you still can do the modification. And the modification could be done in a simpler way than the previous one, because by that time, not everything has been fixed. You still have room to do the modification, so it's much easier and it saves you time as well. So with the pre-certification test, your development cost could be lowered. And not only talking about the testing cost or development cost, is we are talking about the production cost. With easier way of PCB modification, or if you are still able to change the component list, then the production cost will be much lowered. So it ends up with some project saving. This is just an illustration of a look and feel of what is going on. But what's more? Is there any more saving we can do? We can have a cash rebate scheme. The Hong Kong government is now actually offering a research and development cash rebate scheme of 40% of your whole development cost. It is not limited to the Hong Kong manufacturers, but also manufacturers from all other countries. The criteria is using the government suggested research and development centers, including the HKPC, the local universities, and other research and development centers. You can enjoy 40% of cash rebate with your whole development. And the rebate is in 2 sessions. Sometimes you don't need to pay it all the way 1 year or 2 years before you can get the cash rebate. What you can get from the research and development partnership with these centers is you can have the consultancy service provided by our domain experts in smart technologies, in automotive, or in battery charges. And you can also enjoy the whole package of pre-tests supported by these centers. So with this kind of total solution, you can save the project cost by pre-test and also by the government cash rebate scheme. So this is what's the option with the development with the R&D centers. So the major concept of this PowerPoint is to do the pretest plan when you are doing the whole development. And if you are doing it with the R&D centers, you can also enjoy the 40% discount or 40% cash rebate from the government. Thank you.